Hello, everyone. Thank you for joining our zero-touch application delivery with F5, Big IP, Terraform, and Consul webinar. Hope everyone is staying safe and healthy out there. Today, we have HashiCorp's Senior Solutions Engineer, Tristan Stoker, and F5's Cloud Solution Architect, Eric Chen, presenting. They're going to be discussing how F5 works with HashiCorp to provide a complete solution with an automated approach. I'd like to note that the webinar is being recorded, and the recording will be made available after post-processing. If you have any questions throughout the presentation, please enter them through the Zoom Q&A portal, and we'll answer them towards the end. So with that, let's go ahead and get started.
Thank you for that introduction, Allison. So I'm Eric, and either to my left or my right, I can never tell with Zoom, is Tristan. So hello. So to start off, I'd like to just kind of share what we're going to be covering today. Today, we're going to be talking about how we make the network fast. And we're going to be talking about how F5 and HashiCorp are doing this through automation. And following the presentation, we'll be able to see this hands-on. We will be doing a demonstration of this solution using an environment that is built in AWS that is using the automation framework that is provided by both F5 and HashiCorp. So you can see this firsthand, or if you like, you can deploy this in your own environment. Please feel free to use the Q&A during this talk if you have any questions, and we can help answer your questions. So to start, I'll just kind of maybe share some of our poll questions so we can just take a look at what day of the week it is. I have to apologize to the two individuals that believe today is Tuesday and the one that's Thursday. It's actually Wednesday, but I understand where you're coming from. Just taking a look at where people are coming from, it looks like many people of here are familiar with Terraform and Big IP, but you may not be as familiar with the terms Consul and AS3. So you're going to be hearing a lot about these terms as we talk through this webinar today. And then also importantly, it looks like everybody knows what an IP address. That's great. But we're going to be hearing a lot from Tristan about what is this infrastructure as code and service discovery. Since many of you people are familiar with these terms, perhaps this will be a little bit of a review, but maybe you can help educate us too as well along the way if you feel like it. So with that, let's get into what we're trying to solve today. The network is slow. And I'm not talking about just in terms of megabytes or petabytes of data that's being transferred or how many transactions per second, but the network is slow because of process. And it's process that we're all aware of. When I was working in universities before, I actually came from the application team. We were responsible for deploying university applications. We would finish our application and it would be ready to go. But it would take 4 weeks to deploy that application. And it's because we would have to open tickets. We'd go into the system and I would make a ticket to say, we would like a load balancer service. That would go into a queue somewhere, and 1 week later that would get handed off into another ticket queue. And it would go to the security team where they would apply a security policy. That would take another week. For 2 weeks, I'm not really sure what was happening. I'm sure there were tickets that were just bouncing all around the system, but it was a very painful process. So what we're talking about today is how can we look at what was happening in that 4-week process? How can we speed up the provisioning of load balancing services? How can we speed up the process of applying security policy? And how can we remove the bottleneck of the application team always having to open tickets to solve network deployments? So with that, I'd like to talk about how we're going to be solving this problem. Because F5 as a company, some of you may be aware of us, is been around for a long time, and we were part of that problem. We were part of that problem because we had command line interfaces and GUIs that would always require manual intervention. But F5, like many of our peers, is evolving and going through a digital transformation. And part of that digital transformation is providing what we refer to as the automation lifecycle. In a minute, my colleague Tristan will be talking about HashiCorp's tool set, and they use slightly different terminology. And for people who may be more familiar with the HashiCorp tools, I've provided a legend here to try to map some of the terms that F5 uses with terms that HashiCorp uses. So as you think about this process of how do we speed up network delivery, it begins with just how do we bring a device onto the network? And we refer to this as the onboarding process of how we bring the device onto the network. And we've made it possible so that a network administrator doesn't have to be sitting at a keyboard with a serial cable to bring up a device onto the network, whether it's a hardware device running in your on-prem data center or our virtual edition platform that's running on a hypervisor in VMware or perhaps out in the public cloud. We have solutions that can work in a multi-cloud environment. Moving down a step, there is processes of how do we bring the software that's required on there. This is what we refer to as the declarative onboarding process, where we can make sure that we're taking care of these simple networking tasks that people who may know what an IP address is, things like VLANs, all of these kind of basic building blocks is being taken care of as part of that part. The most important part, and this is the part where many of you are feeling the pain point, is how do we automate the day-to-day? This is the process that I was talking about, where how do we remove the ticket process? How do we make it so that we can start to treat our network infrastructure as code? Tristan will introduce this concept of infrastructure as code, but when we refer to application services extension, or AS3, this is how we're facilitating infrastructure as code with Big IP, where we are removing the need to require a command line interface or a GUI and providing a declarative method to deploy network services. And all of this, we're going to see how this can also integrate with HashiCorp solutions like Consul, with doing something that's called service discovery that Tristan will talk about next. So with that, now that we've kind of heard from an F5 perspective what tools we will have to make the network fast, let's see how HashiCorp is helping network automation.
Thank you, Eric. So before we kind of jump into the workflows that we're going to be covering today, I wanted to, give a little knowledge on HashiCorp as a company, because of a lot of our products are a little more prolific than the company name itself. But HashiCorp was founded in 2012. We have about 900 employees, and we've received about $350 million in funding. A lot of that was in 2020, right, with the crisis going on. But we have 6 primary technologies that are all open source, and then we have 4 that are enterprise. And on the screen here, you'll see the 6 technologies. So we have Vagrant, which is for managing virtual development environments. We have Packer for building custom machine images. We have Terraform, which is our infrastructure as code provisioning tool. We have Vault for secrets management. We have Nomad, which is our scheduling solution. And we have Consul for service discovery and service mesh. So we're going to be talking about Terraform and Consul today. And on Consul specifically, we're going to focus on the service discovery functionality and how F5 leverages that.
Tristan, when you were talking about Terraform, you mentioned this term, infrastructure as code. How does that apply to Big IP? How does it apply to how we want to automate the network?
Yeah. So what infrastructure as code does is, in a traditional sense, if you were wanting to configure some resources within Amazon Web Services, you might log into the portal and point and click your way through building whatever servers, network devices, whatever you needed within that subscription, right? Well, when you codify your workflow, you can define all of these resources as code. And then when you launch this, it makes an API call to the cloud service provider to then provision this infrastructure. So by following this workflow and writing your infrastructure as code, it becomes a more repeatable process that you can then automate. So when we talk about this workflow of an application team or an infrastructure team wanting the network to respond more quickly, So if Eric, if you wrote some modules for deploying your F5 load balancers and they're pretty cookie cutter and standardized, those are things you can offer to these teams. And as they build their own infrastructure as code and they set up their application to be deployed, they can just grab the code to deploy that F5 load balancer and you can deploy it. And we also had a question where somebody said, cover more on the bootstrap. Well, not only like when we would provision the F5 load balancer, we're going to be choosing what VM we want it to run on and all of those aspects, but you can even define like an initial configuration. So if you want to like put an IP address for the management interface there, if you want to do some initial routes or any initial bootstrappy type configuration on your F5 load balancer, you can include that in your Terraform.
So does that mean that I need to be a programmer and able to do infrastructure as code? I mean, I heard code, I heard codify, like this sounds like it might be a little bit complicated.
Yeah, it's a good question. So I've never been a programmer myself, had a heavy networking background before I came to HashiCorp. The beauty of Terraform is it's written in a language called HCL, which is very human readable. It's a lot less effort to write than JSON or some of the cloud native tools. And it's really simple to learn. And there's a ton of Terraform code on the web for thousands of use cases that you can plagiarize. So it's really easy to adopt and learn. And we'll be showing some examples of Terraform code so you can get an idea of how it compares to some of the cloud native languages and what it takes to get it implemented.
So when I was giving that story earlier of the pain of just sitting around and waiting for tickets, one of the things that I always felt was really dumb was why, as an application developer, did I have to enter into a ticket? Here is an IP and port for where my web server is. How could Consul help with not having to enter this information into a ticket? Can you kind of talk about what Consul is and how it's helping with that problem?
Yeah, so with Consul, the service discovery mechanism, the way Consul works is Consul's a process. It's going to be running on your services, on your VMs. It could be running on bare metal. It's going to be running everywhere. And what it does is it joins the Consul service discovery mechanism and shows up in a service catalog. So your services within Consul will be defined as what they are, right? Like today in our demo, we're going to be showing some Nginx web servers and a few other things, right? But when these services come online, their node information or the information about the instance is represented within the service discovery mechanism. So in this case, we're wanting to populate some IP pools on the load balancers. F5 will be asking Consul what IP addresses are associated with those services in the catalog. So it'll say, hey, Consul, what are the IP addresses for the web servers that belong in this pool? Consul will respond with the IPs.
I like that because what you've just described is the network device, the big IP in this case, is actually asking Consul for that information. And I think both you, Tristan, and myself, we're not going to have hands on keyboard. So that's going to be the magical part of our demonstration is we're going to be able to make changes within our AWS demo environment. And you're going to see these changes reflected on the big IP without anyone having to open up a ticket. So that's pretty cool to see.
Yeah. And kind of the idea here is with Terraform, we have this day zero, day one scenario where we're building and provisioning this environment. And then after that, Consul is going to be making whatever dynamic updates are necessary to the network device based on how the environment changes.
That sounds good. So again, we're going to be hearing a lot more about Terraform and Consul as we walk through the demonstration in a minute. So let's talk about this solution detail and why it's so important to bring both F5 and HashiCorp together to deliver network automation. So the way that we're going to be accelerating or making the network fast is we're going to take these tools from each of our respective companies and have them work jointly together. So the first part of it is from an F5 perspective, we refer to this as onboarding. From HashiCorp, you would refer to this as provisioning. We're talking about how do we just bring up into the environment the big IP? How do we deploy our network services? So you've heard from the F5 perspective that we have methods of automating the onboarding, whether it's through Cloud Init, which is a common practice for many Linux systems, and how we can kind of define the network through Terraform. So that's kind of the first part. The second part of it is, more of these day two operations is how do we then deploy the network configurations? In this case, it's going to be a combination of, again, using Terraform to deploy the application services extension. What this is going to enable us to do is, instead of having to have somebody with deep subject matter expert of F5, we're going to instead, similar to Terraform, have an agnostic method of defining this is the network services we need. Perhaps you can apply security policy as well, and we'll be able to configure the device dynamically. But wait, there's more. Once this is all deployed, we don't want to have to sit around waiting for a change to happen. So this is where the magic of Consul will come into play, where we talked about this service discovery process, where the big IP is going to be able to communicate to Consul through service discovery to retrieve that information and not have to rely on manual intervention within the environment. So with that, we can kind of dive into a little bit deeper into just, again, some of these values. So we've seen this from an F5 perspective, and many of you are probably seeing this as well. You know, if you'd like to, you can feel free to kind of raise your virtual hand and let us know. But I think many of you are here because you want to know, how can I make the network fall faster? Another aspect of this is what Tristan was referring to as another value, is that many people are afraid of making changes in the network. You might take out the entire network. This could be catastrophic. As we start to adopt using infrastructure as code, we are going to remove that risk, because now the same type of process that our application delivery goes through in terms of code review and audit can be applied to our network deployments. And all of this is going to be applicable whether we're talking about deploying this in our traditional on-prem environment using hardware devices, or whether we're migrating workloads to the public cloud. And maybe on that point, Tristan, could you talk about, what is one of the real values that people love about Terraform with respect to multi-cloud?
Absolutely. So with both of our tools, Terraform and Consul, you can operate them in any cloud service provider. So they all operate in AWS, GCP, Azure. They can operate on-prem as well within VMware, OpenStack. There's not really anywhere you can't run HashiCorp's products. And with Terraform specifically, even outside of providers for cloud service providers, we have providers for over 250 independent software vendors, F5 being one of them. But many of the technologies that you use day to day probably have a Terraform provider to some capacity.
That sounds awesome. So now let's go into our kind of last information quiz. Well, actually, I should mention, you will be quizzed on this information, so make sure you're paying attention. And I think we've already alluded to some of the answers already. But Tristan, can you just kind of, again, walk us through this term service discovery? And again, you will be quizzed on this, so pay attention.
Yeah, so service discovery is essentially cataloging the different services that are operating in your environment, along with including information on the instances that belong to that service themselves. So if you have a service and there's 3 virtual machines that belong to that service, what we're going to be doing is storing information on the ports it needs to communicate on, monitoring the health of those ports, monitoring its IP address if it has an IP address, and other types of information, right? So cataloging all this data and being aware of the status and what is available in your environment.
That sounds good. And before we get into the demo, we'll now do our knowledge quiz, so everyone has an opportunity. I know some of us didn't do so well on what day of the week it is earlier. Hopefully we'll do a little bit better on our questions. Congratulations, so far we're at 100% for correct answers. Keep up the good work. So now, as we're letting that poll run in the background, I'm going to give a visualization of what the service discovery process will look like when we're doing the demonstration. So we've heard this term that there's Consul, that there's big IP. We're going to show how we're going to move away from this ticket process of the application team making a request to the network team to the network devices being able to discover this information from HashiCorp Consul. What I have in the diagram here on the left-hand side is the big IP. So this is the device that's acting as a reverse proxy in this environment. I should mention at this point that This could also be another reverse proxy. Take Nginx Plus, for example. That's another example of a reverse proxy. But in today's example, we're using a big IP for this particular use case. So again, in this scenario, this reverse proxy on the left-hand side is going to be making an API call out to the Consul service. We're communicating through an API because we want to be able to retrieve programmatically all the information about the environment, and Consul is able to provide this information. Consul is going to respond to that API query with the information that we're looking for. Mainly on the right-hand side of this diagram, what we're looking for is what are the IP address and ports of the web servers that are running in this environment. So if we think back to what's the original problem statement, it's I'm trying to deploy an application, or maybe it's these set of 3 Nginx web servers, and the network team needs to go know where it is. In this case, we'll get that information. And because we're making use of F5's application services extension, we're going to be able to dynamically provision that configuration without having to log on to the device. What we'll also see during this demonstration is that we'll also be able to make changes in the environment. And these next set of slides will just kind of walk through what that will look like when we're doing that. And I'll share the poll results. There had to be some folks who believe in Skynet. So I'm sorry, we have not reached Skynet stage yet. And I do think that it would be a popular band name from the 80s. So I do think that that was very plausible. So thank you for that.
Yeah, so, and I think we had one question from Zach Vita. It's, what is a good pattern for deploying multiple IAPS or AS3 configuration? We have about 1,000. We're considering just using one workspace. Is that feasible? So I'll say this, you're talking about one Terraform workspace to provision this entire config? So I'll assume you are. So when you're doing like any type of network device configuration or network security device configuration with Terraform, there's going to be kind of a defined best practice on how you go about that. So when we talked about like implementing a bootstrap config with Terraform, you kind of want to think about the configuration you're using as more of like an initial config when you're onboarding it to whatever, like either central management platform or how you actually manage these network devices. So like judging by the size of your F5 configuration, you may be centrally managing some of these load balancers in one location, and maybe you just want to bootstrap the config of the new load balancer to the extent that it's onboarded by the central management utility. Because if you defined all of that within one workspace and you wanted to make modifications to it, it could be impactful to production services or other things that you may wanted to change on the fly. So if you were to define it and you just wanted, you know, all of the multiple IAPS and the AS3 configuration to exist permanently, and then you wanted to dynamically update the fields within that at runtime, that is when Consul integration could behoove you, right? But I would say really think about such a large configuration that may need to be changed on a regular basis and managing that with Terraform. Eric, do you have would you kind of concur with that on sort of kind of the configuration you mentioned?
I mean, I think in general, what you'll see when we get to the demonstration is that there are many different best practices around using AS3. So if you are kind of familiar with that technology, on our Dev Central blog, there's actually a very nice write-up by one of our engineers on best practices. So I'll make sure that I send that back to you over chat. But you know, I would definitely say that as you're looking at deploying these larger environments, as you're making use of multiple workspaces or deploying lots of applications, that's a great time to kind of reach out to your F5 or HashiCorp team, just so we can better understand, you know, what type of goals you have in your project, and we can make sure that we identify kind of the best type of solution for how you want to deploy it, whether that means kind of splitting that workload up across horizontally. That's kind of one of the practices that I usually see from people who are making the shift from an on-prem to a cloud environment, is how do we take these kind of monolithic type of stacks of infrastructure and be able to scale it out more horizontally. So instead of having this kind of single point of failure on a single device, we can start to kind of distribute that out. So, perhaps we're talking about having, instead of a single device that has 1,000 configurations, maybe it's 10 devices that have 100. But thank you for that question, Zach. And feel free to kind of chime in if you've got additional questions. So we're about halfway through, so we're doing pretty good. So I'll just kind of talk about what I'll be doing. And we'll be doing this as a live demo. So actually, Zach or Tristan, you should have held on to that question, because we could have, filled some time while we were
Oh, we're doing stuff. I can talk forever, so I can show some examples of
sure. No, but
Terraform to cloud native stuff as well while you're getting stood up.
Yeah. So just so everyone, no one gets lost along the way, we're going to be doing kind of 3 basic steps through this demonstration. First is we're just going to stand up the environment. So what we're starting with, this is infrastructure as code. We're going to start with a blank slate. There's nothing in the environment, and we're just going to kind of give you like a very brief introduction on Terraform and what it is. Next, we'll look at kind of the networking aspect of how do we leverage Terraform to provision the network resources on the big IP. And then we'll see the zero touch aspect of it, that now that we've used Terraform to apply this, we'll dynamically make changes within this AWS environment, and you'll see that no tickets were involved, and we can hold true to the title of this webinar. This is an open source demonstration. So if you do want to kind of revisit this demonstration, you could either choose to watch the recording. Allison will make sure that you get the link to that following this webinar, or you can actually download this source code and run it in your own AWS environment if you so choose. And I should note too, and maybe Tristan, you can talk a little bit about this in a minute, that for the demo environment, we're making use of the open source Terraform and Consul tools, but there are some other options, if I understand, from HashiCorp. This is what we'll see once we kind of deploy, is we'll see the devices get up. And Tristan, I'll get you a minute in there to kind of talk about that. We'll see that we're going to be doing an API call. As part of this, you'll see that we're going to include information of how to talk to that API service. So if you remember back to the earlier slides, the big IP is going to be communicating with the Consul service. And once that's all deployed, we'll initially see the services are all green. We'll see that things are happening, and then we'll be able to dynamically scale that environment. So to kind of kick off, let's jump over to our demo environment. So I've gone ahead and I've downloaded this webinar right here. So right now I'm just working out of my own copy of it, but you could also clone this from the HashiCorp repo. I actually got commit rights on that repo, so that's pretty sweet. Within this, if you take a look at the README, there is directions of how to go through this. And maybe, this is kind of funny, I'm the F5 person. Maybe Tristan, you can kind of help explain to me what some of these mysterious HashiCorp commands are. So the first one I'm going to run is Terraform init. What does Terraform init do?
Yeah, so Terraform init is going to look at your Terraform configuration and pull the necessary providers that are needed for when you're provisioning this infrastructure. So like if within your configuration you're defining, F5 things, if you're defining AWS things, it's going to make sure that you have the necessary providers in place to communicate with those APIs.
Is it kind of like that scene in The Matrix where they like plug in and then they say, now I know
Yeah,
Kung
exactly.
Fu?
Like if you need to learn to fly a helicopter, it loads the helicopter, right? So it's exactly like that.
That's pretty sweet. And it seems like The Matrix is having a glitch right now, because right now it's trying to still initialize the plugin providers. So I'm going to execute my knowledge of knowing that I've already downloaded those, and I'm going to go in here and I'm going to go to the next step, which would be running Terraform plan. So what would Terraform plan do for me?
Yeah, so Terraform plan is like a dry run on your Terraform configuration. So you've codified the infrastructure that you're wanting to build, and you run a Terraform plan, and it's going to mock up everything that happens when that configuration is run or when that job's run. So when you go through this scenario, it's going to give you a list of everything that Terraform is going to be creating, any resources it's going to be modifying, or any resources it's going to be destroying. So you'll get an idea of what's going to happen within the environment prior to actually kicking it off, right? So you can get a good idea if you're going to, impact anything that's already in production, destroy anything that's in production, or if you're creating the correct things that you wanted to within your configuration.
And then the last command is, and I guess one of the things that I always enjoy about using Terraform is as part of that plan, you can actually kind of see what all the resources are. And this apply command, now what's happening when I'm running this apply command?
So when you run Terraform apply, you're actually executing your configuration and building the resources in whatever cloud service provider destination you're configured to do so in. So now
I hit yes. So I hit enter.
You should do it. If you did it right, if you looked at your plan and made sure everything was correct, you should hit yes.
And while that's running in the background, let's take a look at some of those files that we're deploying. So you mentioned that there's a thing called a provider. And there's this provider here. So this is, I guess in this case, this is basically informing Terraform how to build a network in AWS. Is that correct?
Yeah, so what the provider's doing is it's when you define this code as HCL, it's kind of like the translation to the API of the cloud provider, right? So when you get that provider, it's mapping HCL to the API of the destination, right? But yeah, as far as the code you have here, you're doing a number of different things. You're defining IP addresses, security groups, networks, the configuration of those resources. So you got a good bit going on with your Terraform configuration.
I probably should have showed this earlier, but when I started with a blank slate, there were no instances that were running here. But now that I've run that command, what we're seeing is, earlier in that file, we were looking at the VPC, and what was happening in the background is that it was actually creating a new VPC in this environment. So this is kind of a case where previously there was not any of the networking infrastructure that you needed, and you can kind of deploy it in this AWS environment. And do you have other network providers for other cloud environments as well?
Yeah, we do. So any like network technology that would be like cloud native, we have all of those defined. We also have providers for like Palo Alto Networks, Checkpoint Software Technologies, a lot of different Cisco products. We have numerous providers for a lot of network and network security technologies.
Very cool. And I'll just kind of mention right now, one of the questions, is it possible to practice big IP with Terraform as lab practice in the home? Absolutely. I think that right now we are talking about using an AWS-based environment, but you could definitely use some of these same tools. I happen to run a KVM lab in my home lab, or if you have a VMware environment, but many of these providers that we've talked about would also function in a home lab environment. The only difference would be instead of importing AWS, you would import a provider that would work within your own home environment.
Yeah, exactly. Like if you had everything labbed up at home in VMware, you could leverage the VMware provider.
All right, so just kind of like a cooking show, I'm hoping that this is kind of baked long enough. So let's first start with taking a look at what has been spun up in this environment. And the first key piece of infrastructure that we want to take a look at is this Consul UI. So you had mentioned, Tristan, earlier that Consul is this runtime catalog. I don't know, it knows where everybody is. It knows where everything's going. So can you kind of talk about what I'm looking at on this screen right here?
Yeah, so in your so this is your Consul server, and on the Consul server we have this dashboard, right? That'll kind of give you a lot of indicators on the health of things and the configuration of certain items, right? So within this lab environment, we're running some Nginx web servers, and then we're running Consul, right? So we see two services here. Now what happened here is Eric drilled down on the Nginx service, and what we're seeing is some information here where we have the node IP address and we have its port that it's communicating on that we're monitoring the health of. So on the right hand side, you see like node checks and service checks. The node is healthy, it's showing up green. The service is operating as well, so it's showing up green as well. If there was some failure, if the node itself had an issue, it would fail a service check and show up as critical within the console dashboard. But what we're looking at here is the relevant information that the F5 wants to pull, and we know that the node itself is healthy and the service is healthy.
Okay. So now, Tristan, I'm going to take you over to the Big IP, and I'm going to talk about what we're seeing from a Big IP perspective. So if you're not familiar with deploying a Big IP in a cloud environment, folks who have worked with our platform before might be wondering, why are we accessing this on port 8443? This is an example of where we're using kind of a single interface where we're accessing the management through that interface. As part of this process, we've also made use of a feature that we have in 15.1 to kind of load the software that we're going to need to use in today's demonstration. So I've been mentioning that F5 has something that's called the automation toolchain. The automation toolchain is something that you can bring onto the Big IP device. So if you've worked with software before, you may be familiar with something that's called an RPM package. What this is allowing us to do is on each of your Big IP platforms, you can install the latest version of the application services extension to make use of the features. If we take a look at some of the Terraform code that we're using in this environment, we're making use of something that's called TMOS declared to deploy the Big IP services in this environment. So in this particular example, what I'm doing here is I am downloading the necessary software that we want to be using for this demonstration. So in this case, I'm downloading version 3.19 of our application services extension. If I wanted to bring down a newer version or older version, it makes it very easy from a Terraform perspective that we're just populating the cloud init information. So if you've worked in public cloud environments, cloud init is kind of a common term of just how you would onboard or provision a device, if I use kind of a HashiCorp tool term. So we're just adopting methodologies so that our customers can onboard the software using that format. Also take note that in this environment, we've done kind of the first stage of building the infrastructure. I guess I'm an F5er, so I don't really know about kind of HashiCorp best practices, but in this particular environment, we've actually broken this apart into kind of a two-step process where we're first building up all of the underlying network infrastructure. And then as a second stage, we're going to be kind of provisioning the network services. So let's go on to that next step where we're going to provision the network services. So now that we've kind of seen that we have the required application services extension on there, the next part of it is that we would go into this AS3 directory. This is covered in the README, but this is a second set of Terraform scripts files. What's the proper term to use for Terraform? Was that like, because I know there's like different ways of referring to.
So yeah, I mean, I hear different things all the time. I usually just call them your Terraform configuration files. Okay. But you can say Terraform scripts, you can say whatever.
And I'm going to be lazy. I'm just going to auto approve it. But as that's running, what I'm going to show you is what we're executing. And this was actually pretty short. So in the previous example, we saw kind of a more complete example of where we were deploying networks and there was lots of configurations. And I think that Tristan in a minute is going to show some comparisons between how you would kind of use different types of templating. But what I want to just demonstrate here is that we are effectively applying a network configuration with very few lines of code. Let me just see with comments how many lines of code this is. So from a Terraform perspective, this is about 18 lines of code. And what the 18 lines of code is a single JSON file. So we have people who are definitely fans of JSON, YAML, or HCL, But what this is representing is instead of your network administrator or yourself having to manually enter in command line interface or go into a GUI to make change, we are informing the entire network configuration, similar to how you can use kind of Terraform to declare your VPC in AWS to declare all of the big IP configuration. And we're connecting it with the ability to communicate to the Consul API. So if I was to kind of take this and go back to where we were looking earlier, we can actually see how the big IP will be retrieving information from Consul. It's going to be communicating over this API. And we're going to see that on the big IP, it's taking this information of what are the IPs and ports of the Nginx web server and update the big IP. So let's go take a look at the big IP now. So on this device, before it was empty, we can now see that there's a new configuration that's deployed. This configuration was deployed by using the big IP provider that we have for Terraform. And if we drill down into the pool configuration, so the pool configuration refers to what are the backend resources of this reverse proxy. If we were to use Nginx terminology, this would be an upstream. So in this case, if we look at the pool members, we can see that there are the two Nginx web servers that were deployed in our AWS environment. So at this point, we didn't have to have any type of, if I had to compare how I would do this traditionally, I would have had to go into each of these servers. I would have to kind of copy and paste the IP addresses in manually into the GUI, and we probably wouldn't have enough time for us to kind of cover all of that during this webinar. So for the last piece, I'm just going to kind of change the number of web servers that we have in the environment as we're kind of letting that wind down. Tristan, did you want to kind of maybe talk about, some of the differences between, why you would want to choose using Terraform perhaps versus using like the AWS CloudFormation template, for example?
Sure. You mind if I share?
Oh yeah, sure. So just to keep everyone honest, what I'm doing right here is I'm going to change this from two Nginx web servers to one. And I promise you, maybe I'll just have to hold my hands up here so you all trust me. I'm going to be, zero touch. I'm not going to touch anything. So go ahead, Tristan.
Cool. Yeah, so this example here is actually, get some of these polls out of the way real quick. So this example here is actually comparing Terraform to ARM. But what we want to show you here is this is a process for provisioning a virtual machine in ARM on the left-hand side and using Terraform on the right-hand side. And what you can see on the left-hand side, if you're new to all this, right? If you've never written infrastructure as code before, is how it's just not very human readable. There's like a lot of formatting going on here, and it's not that easy to read or necessarily understand unless you've had a development background, right? On the right-hand side, you'll see this same configuration done in Terraform using HCL, which you could probably give this to your non-technical manager and he could read it and know exactly what you did. He's like, oh, cool. He's building a Windows VM. It's going into East US and the username is John Doe and the password is, you'll never guess this password, right? So it's very human readable, very easy to follow and write. And then through like our public module registry and other sources through our partners' GitHub environments, there is a ton of Terraform already built that you can leverage so you can get started with this very quickly. One thing Eric did mention is you're kind of seeing him go through a CLI workflow with Terraform right now. Terraform open source is completely CLI driven. Our enterprise solution, we centralize Terraform and secure the backend storage for Terraform. And we offer a UI workflow, an API workflow, and a CLI workflow as well. So a lot of the issues where if you have multiple teams wanting to collaborate and centralize your Terraform configurations in one place, the enterprise solution helps you do that.
Well, thank you for that, Tristan. And I think you may have just bought me enough time for us to kind of see the grand finale. So
Cool.
Drum roll, please, Allison. So let's finish this out. So I believe right now, if we take a look at our AWS environment, and I promise you, while Tristan was talking, I was sitting on my hands, so I did not actually make any changes to this environment. There's nothing up my sleeve, so to speak. We've gone, actually it looks like they're still coming up, but we've added 2 additional Nginx web servers into the environment. So you can kind of think about this scenario where you have some type of peak traffic event, you scale up the backend, and now we are solving a problem of, instead of you having to pick up the phone to say, hey, network person, please make this change, we're going to see how we're making use of Consul and service discovery to solve that issue. So the first place I'll jump back to is, if we look at the Consul UI, is that it now shows that we've got 4 Nginx web servers here. So just recap, Tristan, how did we learn that there were those 2 additional nodes? What was taking place?
Yeah, so when those Nginx web servers were provisioned, they had the console binary on them with the configuration for this specific service. So as soon as they came online, they authenticated to the console discovery mechanism and joined this service, and are now represented within the dashboard in the service discovery module.
So for the 2 people who answered that they believe that service discover or infrastructure as code is like sentient, the military Skynet, that kind of feels like Skynet, where it's like these Nginx web servers were reaching out and informing it. So I think we have to be careful about where this Consul technology is headed. So let's head over to the big IP, and let's take a look here. So from the big IP perspective, we're still showing that there's 2 pool members here, and this is more of an artifact of our UI. We don't have the fancy UI where it kind of dynamically updates on the back end, unlike Consul. But if I do something very simple, where the one touch I will do, so not a perfect demonstration, is I'm going to click on pool members just to refresh your view of it. I actually haven't added anything. So again, nothing going on here. We can see that the big IP has picked up that change. So again, what was happening in the background, if you go back to the slides that we were showing earlier, is that through the application services extension and our service discovery mechanism, we are in constant communication with that Consul service. So from a communication perspective, you can think about these backend application servers, in this example, Nginx web servers, are communicating to Consul to say, hey, I've been added to the environment. And then the big IP asking Consul to say, is there anyone else to invite to this party? And now we can see that the Nginx web servers got added, and that concludes our demo. So we now have got about 10 minutes to go, or perhaps maybe we'll kind of let people break off earlier if they want. But let me just kind of take a quick look back to the Q&A, and I'll address one question, which is from Sandev, which is, can you quickly show your Terraform code that built the F5? And there's another question about the Consul config that I'll let Tristan jump on. So again, and I'll shoot this out over chat just so that it's in everyone's, available to everyone, is that all of the code that we saw in today's demonstration is available on GitHub. So you can run this in your environment.
Yeah, so Zach, if you go to this repository that Eric's linking, it's going to have the Terraform and the Consul configuration within that repo. And
just to help both Zach and Sandev out, I'll just kind of point you to the kind of 2 places where you would want to look. So the important part is the provisioning part is in this subdirectory Terraform. This is kind of where we're kind of doing that first step of the demonstration, where we're provisioning the big IP device, and that was kind of the source of your question. So that particular code is in this F5 TF file. And if you look through it, it looks similar to how you would deploy a traditional Linux web server in AWS. The difference being in that other file that I showed earlier, which is under scripts, we're making use of the TMOS declare to kind of add the application services extension. On the Consul side, I guess it's a question of whether they wanted the agent or the server. I believe this is how the Consul server is being installed. And then I believe the code for the agent is within this file right here. You can kind of see where it's kind of doing lots of fancy things to get that up and running. But, you know, fancy is relative.
Yeah, and what we'll do, Zach, if you just want like the console agent configuration, we can abstract that from the script and just put that config file in a different directory in that repo if you want to reference it. But yeah, I imagine that's something people would like to see.
I've got a question for Allison. Maybe a little early to ask, but where will this video be made available?
Sure. So we'll have it on the HashiCorp website, but then I will send that link to everyone that registered for this webinar.
And now we're just trying to catch up with some of these questions here.
Yeah, so Frank asked about Terraform provider support for BigIQ.
And I'll just read it out for the recording. In environments leveraging BigIQ, are there any Terraform hooks there? I'll generalize to say that when you're using Terraform and you're deploying something like BigIQ, that there are kind of similar methodologies of being able to kind of take advantage of Cloud Init. If you look on our Dev Central site, we do have some examples of kind of a quick start. And that would be kind of a good foundation of how you could kind of transfer some of those examples. Those particular examples are making use of Ansible. But what I want to point out on this is I mentioned earlier that F5 has this automation tool chain. Our approach in providing automations is that for all of our automation partners, you know, you kind of heard that that HashiCorp has many network partners. We also have many automation partners, is that we are providing the same foundation so that many of these automation tools can take advantage of our automation with minimal overhead. So all that to say is that if you take a look at some of the Ansible examples that we have on our GitHub repo, those can be adapted into Terraform. You know, it's just a matter of understanding how to do some of the syntax changes. I'll throw you this console question to you.
So Sendev, can Consul also add custom send and receive strings automatically to the HTTP monitor to make the health check more efficient? You can. So there's, when you're talking about getting into this, I'll give some links to Allison when she shoots out the follow-up, so you can reference some documentation specifically to like custom actions you want to do with Consul and other things. And also, as kind of a follow-up to this webinar, F5 and HashiCorp recently finished a hands-on instructor-led training environment where we build this integration in our own lab. You'll get hands-on experience with F5, hands-on experience with Terraform and Consul as well. So if we've been doing it as a kind of like a regional-based thing, and we did one for the Colorado region yesterday. But if you're interested in seeing this, let Allison know. She can communicate with Dave, and they can get kind of like a public console training session coordinated for everyone to, you know, get their hands on it.
And I'll also kind of mention, just because on the topic of lab environments, that the demonstration that you saw today was done in what we call internally the F5 Unified Demo Framework, which is a classroom tool that we use during our annual agility conference. So, you know, if you happen to be an F5 customer and you're kind of interested in seeing this environment as well, you know, a similar that you can just kind of note in follow-up that you might be interested in that. Again, we make the source code available. That's probably the most direct way that you can get access to the environment. But if you do want to run it in our own lab environment, we do have that also available for our customer and partners as well. There's a question that kind of came in over the chat that I'll kind of bring up, and perhaps we'll leave this as the last question. What about the monitoring telemetry with Consul?
Yeah, so with Consul, like we have that agent configuration that we were using in our lab environment today, which was just simply monitoring port 80. But you can build much more robust monitoring configurations for a number of different things and different types of status checks you want to do on the different nodes. But what we can do is I can add some additional documentation into the follow-up materials that Allison's going to provide. And if you have any other questions, you can feel free to reach out to me or your HashiCorp sales team.
So just to review, I think we've all learned about what infrastructure as code is. We've learned about service discovery. And Tristan, I don't know if you're on my left or my right, but we've also learned how with HashiCorp and F5 automation that we can accelerate the delivery of network services. So that's very excellent. So I guess from the F5 side, thank you all for joining us today. Tristan.
Yeah, thank you, everyone. We appreciate the attendance.
And with that, Allison, you can do the hook and pull us off.
Sure. Thank you so much for your expertise, Tristan, Eric. Again, this session was recorded and we will make that recording available on our website or via email. Hope you all enjoyed today's webinar, and that just about wraps it up for us. Have a great rest of your day. Thank you.
Naveed, I don't know if you left, but you can use it on a hardware-based F5 too. Same APIs exist, so if you wanted to bootstrap a hardware load balancer, you absolutely could. You bet.
I think you're the host, Tristan, so I think you actually get to shut it down.
I have to close it down. All right, I'll do one last call for any buzzer beater questions coming from anyone.
I think we're good. Let's shut it
All right.
down.
Shut it down. All right. Thank you, guys.